So now we can use synthetic division or even long division if you wanted to write a polynomial in factored form. Now it's important to be able to write the polynomial in factored form because you want to be able to find the x-intercepts. And using the zero property is our favorite way of doing that. So this question says, write the following polynomial function in factored form if 2 and negative 3 are x-intercepts of its graph. Okay, so what does that tell us? Well, if 2 and negative 3 are x-intercepts, then we know what two of the factors are. We know that one of the factors is going to be x minus 2, because this factor would give me the positive 2. And we know the other factor, it would be x plus 3, because that would give me a negative 3 if I was, solving it using the zero property. So how are we going to use that to finish factoring this bad boy? Because this guy is pretty big. He has 1, 2, 3, 4, 5 terms. There's no special way that we know how to factor this. This is what you guys can do. Now first double check to see that it has all the terms. It has all the terms. So once you know it has all the terms, then you can use synthetic division to divide out the factor. So first, let's divide out this factor right here. Now if I want to divide out that factor, do you guys know what would go in the multiplication box? A positive 2, right. Now the positive 2 is the answer, and if you were looking at the factor, it would still be a positive 2. Remember, because you always think the opposite of what's in there. So let's write down all of our coefficients. We have 2, 7, negative 4, negative 27, and then negative 18. Well, this is a big one. Alright, put my dots right there. Alright, bring down the first one, because that's what you always do. So we have a 2 right there. Our next number, what's this number right here?
4.
Yeah, that's 4, because we multiplied 2 times 2. And then we get 11. Now what's this number? 22. So I put a 22 right there. I add them together. I get 18. Ooh, what's this next one?
36.
Yeah, 36. How do we get 36? We added the 18 I'm sorry, not added. We multiplied the 18 and the 2. Now if we add the negative 27 and the 36, we get 9. Now what's the last number going to be? It's going to be an 18. Now that's important. We should get a 0 for our remainder, because the problem tells us that that 2 is one of the solutions. And so if that's one of the solutions, when I plug a 2 in, I should get a 0 because it's on the x-axis. It's an x-intercept. So now we have our new polynomial. Here's our new polynomial when we factor out the x minus 2. Now I didn't put all the other x's on there. It should be, that's a plus right there. That would be an x, not x squared, just an x. And then this would be the x squared, and then this would be the x to the third power. But we don't need those x's yet. We don't need that polynomial yet, because we got to synthetically divide out the x plus 3 also. So we have a new synthetic division to do. We're going to put our multiply box here and put our new coefficients down. You guys see where I got the 2, 11, and 18, and a 9? In our multiply box, we're going to put a negative 3. Get our bar going here. Alright, first number is 2. What's this next number going to be that I'm going to subtract from 11? Negative 6. That's right, because we have to go 2 times negative 3. Now add the 11 and the negative 6, you get 5. My next number is going to be negative 15, because we have to go 5 times negative 3. And I get a 3. And what's 3 times negative 3? Negative 9. We got a 0. And again, I want to stress this. We should get a 0 for our remainder if these are actual factors. It's kind of like if you had 45 and you divide that by 9. I should get a remainder of 0 if 9 is a factor of 45, correct? Yeah, I would. So Same thing here with the polynomials. Alright, so now what's our leftover polynomial? What's the polynomial that we have right now? Yeah, now I like to work backwards. I start with the constant, so positive 3, and then my next number is the 5, and that's going to be the x term. My next number is the 2, that's going to be your x squared. So now what do you have to do with this to finally write it in full factored form? Yeah, we got to factor this guy. So we have 2x squared plus 5x plus 3. We have to factor it out, so we get 6 on the top, because we go 2 times 3. We're using the big X to help us out with this. 5 on the bottom. Now what times what will give me 6, but then add to give me 5?
3 and 2.
Yeah, 3 and 2. Okay, and then we have 2x squared plus 2x plus 3x plus 3. So I got rid of this 5x and I put 2x plus 3 because that's what we got from our big X. Now you use grouping. So the first 2 I can take out a 2x, so I have a 2x. And then let's see, 2x squared divided by 2x, that'll be an x. 2x divided by 2x, that's 1, so I plus 1. What can I take out of both of these guys? I can take a 3 out, so I have plus 3, x plus 1. I take out an x plus 1 from both of them. I have x plus 1 times 2x plus 3. And those are my other factors. X plus 1, 2x plus 3. So this is our answer. This is what f of x is in factored form. Now this becomes very valuable. If you know how to do this, then you also have the ability of finding the other x-intercepts. 2 of our x-intercepts are 2 and negative 3, and we get that from these 2 factors. What else? What are the other x-intercepts? Can you guys tell me? Yeah, one of them is going to be -1. What's this one going to give you? -3 over 2. Okay, if you set it equal to 0, those are going to be your other 2 x-intercepts. That's not what this question asked, but I just wanted to make sure that you guys saw that you guys knew that.